Hi, this is Byron Acohido, lastwatchdog.com. Joining me today is Himanshu and Doug from Data Theorem, a leading security company in the area of API, application securities, especially APIs. So we've talked a number of times, and great to see you guys again. Thanks for joining me.
Thanks for having us.
Thanks for having us, yes.
Okay, we got a great conversation set up today. So to set the foundation, let's I wonder if we could drop into this notion of full stack attacks. And this is my understanding of it, and you guys have helped educate me about this. Full stack attack, what do we mean by that? It's when the bad actors are scrutinizing client-facing apps. They're keeping an eye out for freshly issued APIs, especially in new apps or in software updates.
It's really the same idea that an attacker would have 20 years ago, but implemented differently. So let's take an example where I want to hack X, Y, and Z. I don't like them. They did something mean to me, or I can make money off of them, right? So 20 years ago, I go and see where their IP addresses are registered. I do an errand lookup. I start profiling their network. I do all these things to basically build, at the time, it's called the attack tree. Now it's just called attack surface management, right? Now, fast forward 20 years, I can't do that, right? Because everyone's in the cloud. I don't know where anyone's hosted. I don't know anything. Everything is AWS, GCP, and Azure. So how do I get access to their data that I want to monetize or I just want to embarrass when I don't know where the target is? Now, again, I'm a true hacker. I'm not a pen tester. And why I'm making the difference, I'm not looking for a cross-site scripting issue. I can attack one person with that. I'm not looking for CSRF. I can attack one person with that. I'm looking for thousands, if not millions of records. So of course, I'm a hacker, so I'm determined. So what do I do is I look at the clients. The clients can be IoT hardware. It can be mobile apps. It can be web apps, especially single page web apps, or B2B API. So that's where full stack starts. Full stack starts at the top where you're looking at the client and you're testing the client, but you're testing the client not to find cross-site scripting and stuff like that. Yes, that's kind of nice and cute, but like, what does the client tell me about the server? And the server is not your 1980 server, it's your cloud instance. So it's not a server at all. It's not a web server. It's an API running on Lambda. So now I have this mobile client or this web client or this IoT hardware. Let's stick with IoT for a second. I have this IoT hardware talking to a server endpoint, which is an API running on Lambda. And now I have my attack surface. Boom, I got my attack surface. And now I start testing that API. This is the full stack attack. I went from the IoT client hardware to full stack IoT. Full stack API. And from the API, I see they have some S3 buckets supporting that API. And bam, I have my target and I have my hack.
So Doug, we've talked about this, but just in what Himanshu framed there, this notion of the bad actors, there's gazillion APIs being produced at a high scale. So the smart thing to do is to pay attention to the updates and that sort of thing. Can you frame that a little bit for us? That's kind of where the action is taking place, is it not?
This kind of graffiti of doing things just for the challenge of it. Those are the old days. The days of now are to get large troves of data to monetize it. They're mostly financially motivated. And this whole idea of full stack came from the idea of a full stack engineer, which really came about because of the advent of the agile development process and DevOps, right? What you started to realize is that you couldn't just write code and then have other people run it for you. And you couldn't have the people who ran code and have no idea how to fix and update and change and give you the feature velocity. Those teams got smashed together in this process and this kind of cultural phenomenon of DevOps. And these full stack engineers started popping up. But unfortunately, security didn't create full stack security engineers to go along with full stack development engineers. And but attackers did go about the fact that development now had the power to control everything on the back end. So when they developed a brand new feature that expressed itself typically like in a mobile app or a web application or some sort of human interactive application, that engineer was now coding not just that front end and the software process, but it was coding all the way down into global infrastructure. Mm-hmm. And global infrastructure touched the globally available data stores where millions and millions of records resided. And so because of that power, the power of a developer mm-hmm. started doing things that made IT not really the architects of what's going on on the back end. The developers now architecting the whole system, the full stack. And as a result, the attackers were realizing we could pull off full stack attacks, going client, network, which is API, and then the backend microservices that are ephemerally spinning up and spinning down in the cloud.
It strikes me, and I'm not technical, that the opportunity is being created because, as you described, the developers are all powerful. They're doing everything. They're making rapid changes to help the company be agile. But where the rubber meets the road is that the APIs is where they're making these flexible connections, and every time they change it, then they don't. That's where opportunity is somehow for the bad actors.
I don't know if this is not a perfect analogy, but the thing about it is if you ever watch lions hunting herd animals, right? The lions have like this teamwork. They're very coordinated in what they're going to do to hunt prey. Mm-hmm. They're not usually going after the strongest, most resilient, most durable part of the herd. Mm-hmm. They're looking at the part of the herd that is brand new or is underserved or underprotected or old or dying off. And attackers are no different. They're looking for the weak link, right? Security has always been a weak link driven system. So if a new piece of software was just added on an update, the likelihood that's gone through hardcore security vetting and reliability testing and all the different kinds of fuzzing attacks that can occur, like unlikely. So if you're an attacker, why would you go after the thing that's most resilient, the strongest, most durable part of the system? You're likely going to go after the weak link, and that is the easiest prey to attack.
What I'd like to talk about with that great description of kind of what the landscape looks like and where the opportunity is this notion of the approach being attack surface management. That's kind of
because it sounds so standard, but it's blocking and tackling. Blocking and tackling, it's the basics, but turns out the basics are quite hard when you have a moving target. When you have, again, 20 years ago, how many servers do you have? I have 1,500. Prove it. I have the bill here. Today, how many servers do you have? I don't know. At 3 o'clock in the morning, I have 1,700. At 3 o'clock at night, at 3 o'clock in the afternoon, I have 3, right? Because I'm Netflix or I'm a streaming app. So things are ephemeral. Things are there and then they're gone. And so blocking and tackling, if I can use that analogy, is normal if you have an offensive line or a defensive line. But if there's a lineman that disappears all of a sudden and he or she shows up 6 hours later, it's like, what? Like, what is my inventory? And if I have an inventory, and more power to you if you do, does it get auto updated? And if it gets auto updated, more power to you. Does it get auto secured? If it gets auto secured, more power to you. So that's the problem. Inventory that's auto updated, and seeing if said inventory has to have any kind of security testing on it automatically. That's what attack surface management is. It's getting my inventory management, and then understanding automatically are basic attacks, is it vulnerable to basic attacks, and not having a human involved in that because there's not enough humans to track all the assets that you may or may not know about.
So blocking and tackling, it's, if you're my Seahawks, it's pretty easy. There's 11 guys on the other side of the line. But in the world we live in, the digital world, you've got stuff like shadow assets, advanced APIs. We talked at length about, GraphQL. Am I saying that right?
Mm-hmm.
API.
That's right. Mm-hmm.
frame that for us, just kind of at a high level. Well, how does all the new stuff make this even harder?
So, if you were a large bank, a large healthcare provider, a large retailer, manufacturer, right? And obviously a tech company, and the tech companies kind of spread across every type of industry, right? Software is eating the world. Software is eating every industry. And COVID sort of exacerbated that. But what the cloud really does is it allows a developer to write less lines of code, less unique lines of code, and deliver more and more functionality to customers, right? And there are things that the cloud is now doing with machine learning, artificial intelligence. And then, of course, we keep talking about this kind of ephemeral scale up, scale down infrastructure, best expressed by serverless, or they call them cloud functions, or in the case of Amazon, they call it Lambda. Yeah. As a result is like back to what Himanshu is saying, is that your inventory is never static, right? It's never static. It is a moving target. It is hyper dynamic, and it makes it extremely difficult to take these static constructs like firewalls, right? Or static constructs like operating system agents. These are two tried and true security tools and techniques that we've been using for about 20 years because the data center was typically pretty static. Like once you stood it up on an enterprise app, you knew what you had, right? Like Himanshu said, this many servers, this much storage, this many network locations, and you started sticking up firewalls and agents on operating systems, and you were okay. But if all of that is dynamic and all of that is not even known by the customer running their application, right? At one point, like Himanshu said, in the middle of the night, you only have one instance in one availability zone, maybe in San Jose or in Ireland or Northern Virginia. And then at peak traffic hours of business hours, you have availability zones all over the planet. Your attack surface is completely different. At any given moment, your attack surface can be different on the same application. And so you need tools and you need techniques that work with that kind of architecture and that kind of model. And admittedly, Data Theorem is one of the innovators and contributors to helping customers deal with that. But we're not alone, right? The good news is there are a lot of innovative companies who are now evolving these security techniques and these runtime protection innovations to deal with this hyper dynamic environment that's being driven by cloud native apps.
We've established that we're no longer in a static networking environment. It's quite the opposite. It's non-static. It's highly dynamic. It's ephemeral. I like that word. That's a good wordsmith word. So Himanshu, pick up where Doug left off. This notion of active protection.
Essentially, active protection is where I think security is almost ready for. I think developers are ready for it. Security is probably a couple years away, but obviously companies like us and many others are on the forefront of it because we see where it's going. So essentially, attack surface management. Why are we even talking about that? Is that a vendor buzzword? The answer is no, because when hacks happen, public or private, it's usually, sadly, it's usually like, what? Who knew about this? Like, I didn't even know this one existed, right? So a CSO can only say that a few times before they say, okay, we have an inventory management problem, right? Now we got attack surface management. We're good, right? So now is like, okay, now that I know it's there, I have one server that pops up at 3 o'clock in the morning. I know it's there, great. But when it has a vulnerability, guess what? I don't have staff at 3 o'clock in the morning, or maybe I don't want to have my staff person that event. So how can I know that if there is an event at 3 o'clock in the morning, it gets noticed? So I think instead of the IDS, it's active protection. It's like, okay, hey, developers, now we have an inventory. We know when things are coming down and up, and now we're going to protect certain assets if they have a high risk data element to it. So when we see a API issue in the middle of the night and we see it's actually leaking data, we will automatically protect it so it doesn't become a breach.
How would you sort of summarize or categorize the main components of active protection?
There's certain pillars in security that we always think about: authentication, authorization, encryption, and auditing. And the reason why these four pillars always come up as foundational practices in security is because they can be applied everywhere. It's like, who's getting access to what, when, and do we have a tracking mechanism to ensure that whoever is providing privileged access to assets, applications, data, that there's a record that can't be tampered with. And so if you can actively enforce these four pillars at all times, no matter how dynamic the nature of your APIs are, no matter how dynamic the nature of your cloud services are, no matter how dynamic even the client layer of modern web and mobile apps are, if you can maintain those four on a consistent basis, then you're doing extremely well. Now, admittedly, when developers wake up in the morning and they're out there innovating for the business, making customers addicted to these applications and delivering really cool insights and cool new services, I assure you, they're not thinking about these four pillars the way that security is, right? It's not what drives them. If they do these four pillars, but the app is unpopular or the feature is low value, it kind of doesn't matter, right? And so this is the crux of innovation. At the end of the day, when you're innovating on the app, you have to help make more money, drive revenue, drive insights, drive entertainment, drive something that makes humans get value out of the app. Security is driven by a completely different motivation, right? It's like, I have to maintain these four things actively all the time. And what active protection means is, how do I get these four pillars actively in place in a very dynamic environment?
It's the old problem,
That's the
right?
trade-off.
It's the dial problem.
It's the dial problem.
That's the question I was asking. The technology of the dial is available, but to dial it way up if you want, but we're back to that same problem of
but in some situations, what you're going to notice is, if you're a business that's been used to running on a data center where you have this perimeter wall and layers of perimeter walls around your most important protected data, and then all of a sudden you have a development team building in the cloud, that data has none of those walls by default. And so now the data lives directly on the public internet. What's beautiful about that is, man, the ability to manipulate and get access to that data is fantastic. They try to put these walls back up again, and then they fail, right? They take a standard firewall from the old world of traditional IT data centers. They try to stand those things up in the cloud with this kind of ephemeral scale up, scale down technology, and it fails because there's not one instance. There's like 0, 10, dozens, thousands of instances.
You said something, Himanshu. Active protection, developers are ready for it. Security is not. What did you mean by that? Okay.
It's the nature of our industry. So the question is, do you want 700 million records out on the internet, or do you want to get yelled at by the VP of engineering? And those are the only two choices, right? So traditionally, security says, hey, don't yell at me. Like, if Doug is the VP of engineering, I'm going to be like, okay, I'm not going to auto protect because I've been chewed out by him. That's revenue. And Doug owns revenue. He's the VP of engineering. I'm not going to do it, right? But on the flip side now, in the new world we have, where you have millions of records and you have fines and jobs associated with them, that's the wonderful part of security. You have two bad choices. Choose the least bad choice. And that's where I think security is not ready for. So active protection, just like, and it's not just me saying it. If you look at a WAF in 2008, 99% of WAFs in 2008 were run in passive mode. They had the technical ability to be in active mode, right? Imperva and all the WAF vendors had that ability, but they run in passive mode because why? You just don't know what's going to break. And I applaud that and I agree with that. But now, what you don't know what's going to break could have a significant side effect. Now, things are a lot better than 2008. We break less things, but we still break things as security. But that's where I think security is not ready, where developers are like, listen, we can't have our APIs leaking data. So yes, if there's a couple Scars on our face, we're okay with that. But we need to have this automatic. And I think that's where security is a little bit more of an analysis paralysis, me being part of the security community, where developers are like, no, automate it. If it can auto fix, let's do it. And we'll correct the side effects as they go on. Because we know it's going to save data, and automation is where we're going to get to the promised land.
And the breaches aren't stopping, and the compliance pressures aren't stopping. I mean,
the other thing that has happened to security professionals is that there has been incredible amounts of investment in security startups and security companies who've tried to bring tools to bring innovation. But sadly, what has happened, and I was a former VC, venture capitalist investing in security companies, and what has happened is that sometimes the security vendors overpromised and underdelivered, and it showed up in the form of false positives. They would ring the alarm on something that wasn't really worth ringing the alarm for. And so as a security professional, to deploy an active protection technology, which would, and let's be very clear, would actively block something that was viewed as not real business transaction, but rather an attacker doing something they shouldn't be doing. To do that active block or active protection, at that point, if you blocked a legitimate business transaction and caused the business a lot of money or dissatisfaction from a customer, nothing makes a security person more fearful of that, with the exception of a breach, right? So this is the weird place where you are, is that if you don't trust your vendors as building good technology to help you, then you're reluctant to deploy them in an active way where you could falsely block a legitimate transaction and as a result, stop the business.
Well, gentlemen, that's a terrific discussion. And I've got 2 or 3 questions here that could launch us off on, 2 or 3 more discussions that spin off of this. But let's stop here and, think about this. Really good information. And I've learned a lot again. So appreciate your time. Thanks so much for sharing.
No problem. Thanks, Byron.
Thanks, Byron.